Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.67. While solving this problem, we will be using current divider rule. Basic equations for the calculation of current I1 and I2 of this particular circuit using current divider rule is provided here. We also will be using parallel equivalent resistance calculation formula of two parallel connected resistances. R equivalent of two parallel connected resistances is calculated by taking the product of both resistances dividing by their sum. Now move towards the problem. Exercise problem number 2.67. Find current I1 and voltage V0 in given below figure. This is the circuit diagram of given problem. We have to find value of current I1 inside this branch and voltage V0 across this 4 kilo ohm resistance. So without wasting time, let's proceed towards the solution. First of all, we will try to simplify this network in order to calculate total supplied current of this network. Later on, we will apply current divider rule to calculate the current of this branch. The remaining current will flow from this branch, and after finding the value of current through this branch, we will be able to calculate voltage across this 4 kilo ohm resistance, that will be the product of current through this branch and the value of resistance. So first of all, we will try to calculate total supplied current. For that purpose, we will simplify this network. This 4 kilo ohm resistance and this 8 kilo ohm resistances are connected in series connection. We can find their equivalent resistance and replace these two resistances with a single resistance that will have the value of both resistances. Equivalent resistance of these two resistances will be equal to the sum of both resistances. 8 kilo ohm plus 4 kilo ohm, it will become 12 kilo ohm. Modify the circuit. Now these two resistances are converted into parallel connection, and we have to find their equivalent resistance so that we can calculate total supplied current through this branch. For that purpose, we will use this equation to calculate their equivalent resistance. In this case, 6 kilo ohm resistance will be R1 and 12 kilo ohm resistance will be R2. Place values inside this equation. Product of 6K and 12K divided by the sum of 6K and 12K. Product of 6K and 12K will become 72K square divided by the sum of 6K and 12K will become 18K. 72K square divided by 18K will become 4K. So we can replace these two resistances with their equivalent resistance having the value of 4 kilo ohm. Modify the circuit. Now we can calculate total supplied current by using Ohm's law. Current through this branch will be equal to total supplied voltage, that is 12 volt, divided by total resistance, that is the sum of both resistances 2K and 4K. IS will be equal to 12 divided by 2K plus 4K. Solve this equation to calculate total supplied current, that will be 2 milliampere. So we have calculated current that will pass through this branch and it will act as total supplied current in original circuit. Modify the circuit. 2 milliampere current is flowing in this direction that we have calculated in previous step. Now we will apply current divider rule to calculate current of this branch. For that purpose, first we have to label both branch currents. This branch current is I1 and this branch current will be I2. Now we will use current divider rule to calculate value of current I1 using this equation. I1 is equal to R2 divided by R1 plus R2 multiplied by I into T. I into T is total supplied current. In our case, it is 2 milliampere. R2 is the resistance of opposite branch. In our case, it is the sum of 4K and 8K. Total resistance will be 12K. And R1 is the resistance of same branch. In our case, it is 6 kilo ohm. Place values inside this equation to calculate the value of current I1. That will be equal to 12K multiplied by 2 milliampere divided by 6K plus 12K. Here 12K is the sum of both resistances. Take the product of 12K and 2 milliampere, it will become 24 divided by the sum of 6K and 12K, it will become 18K. Now divide 24K with 18K, the value of current I1 will become 1.33 milliampere. So we have calculated the value of current I1 inside this network. Now we can calculate the value of current I2 as well using Kirchoff's current law. On this node, only one current is entering, that is supplied current, while two currents are leaving from this node. So the value of current I2 can be calculated using this equation. I2 will be equal to Is minus I1, total supplied current minus this branch current. Place the values of both currents. I2 is equal to 2 milliampere, that is total supplied current, minus 1.33 milliampere, that is the current of this branch. So the value of I2 will become 0.67 milliampere. We have calculated the value of current through this branch. Now we can calculate voltage across 4 kilo ohm resistance by taking the product of current through this resistance, that is 0.67 milliampere, and the value of resistance 4 kilo ohm. Voltage across this 4 kilo ohm resistance will be 2.68 volt. So the value of current I1 inside this network is 1.33 milliampere and voltage V0 across this 4 kilo ohm resistance is 2.68 volt. So this was exercise problem number 2.67. Thank you. See you again in next video.